I will give you helpful hints and pointers, which will be very, 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 very helpful. All right, somebody are
This is like in my lockers. Can I go get it?
yes, by all means. Somebody said one already. Which one?
8.
Number 8, children. Number 8. Please understand this, and this would be my job, because probably on tomorrow it's going to look a lot like that. You will notice something different about problem number 8 in that it is only a 2-term thing that's equal to 0. Okay? If that's the case, you're not really going to break it into 2 binomials unless it's one of these. That can be broken into 2 because it's r squared and a number. This one has m's there. If you see this, you are just going to ask yourself, your goal is to factor this. If you have m squared minus 7m equals 0 and you need to factor this side, okay, you want to factor it because you want 2 things that are multiplied together, because when you multiply 0 by something you get 0, and that's your goal. So what can you take out of both of these? Just a single m. And feel free to put in parentheses, it doesn't matter. If you take an m out of these 2 things, you're left with an m minus 7. When you take m and multiply by m minus 7, you get this, it equals 0. Then you ask yourself, when will these parentheses be, what does m have to be to make these parentheses 0? Well, this one's pretty easy because it's just a single m, so m is 0. And this one, what number when you subtract 7 from it gives you 0, 7. So those would be the 2 answers there. Whereas these, you're just going to factor in the 2 binomials, and then look and see when they're equal or whatever. More. I know there's more out there somewhere. Ariel? Number 1. And again, that was one of those things where we said it's a special case one. Trinomial means it has 3 terms. This one only has 2. And in order for this to be factorable, it has to be 2 perfect square numbers. In other words, you multiply the same thing by itself to get to that. Because the only way for the middle term to drop out is if you have the same thing in both binomials, except one is positive, one is negative. Because if you have a positive 3 and a negative 3, when you get that middle term, you get your r squared. Negative 3 times r is negative 3r. Positive 3 times r is positive 3r. They're opposite, so they go away. So you have no middle term, they drop out. Just like this. If it was this, if it was t squared, please work. If it was t squared minus 16, what would that factor into? Michael?
3 minus 4.
Right. This has to be a perfect square. If it was 17, you could not factor this. But since it's a perfect square, it's going to be t minus 4 times t plus 4. The only way it works is if this is a perfect square and this is a negative. This, if there was a plus there, wouldn't be factorable. You can't do it because there's no way to get a positive when you have opposite numbers there. So it has to be both perfect squares and a negative. What you had to do. And notice, people, understand this. These first 4, the directions say to do what? Just to factor. Okay? Factor means you just split it into what times what. Okay? This one says to solve by factoring. So you have to factor it, and then when you factor it, you're going to get 2 answers. You have to tell me what m equals. Up here, you don't tell me what m equals. You just say, okay, that's r plus whatever times r minus whatever, or whatever it is. There's a difference between these 2. You do the same thing, just when you go a step farther. Lutz.
Number 3.
Number 3. What is the number 1 rule, children, when you're given, if you look back in our notes, when you're given something to factor like number 3, what is the first thing you're supposed to look at? Jake, yes. And you look to see if there is a common factor between all 3 right away. What number can you take out of 4, 24, and 28? That would be a 4. And then you're left with m squared minus 6m minus 7. Then, and that 4 stays on there, then you look to see what you can break those 2 into. Can I factor m squared minus 6m minus 7? Well, I put an m here and an m here. 4 out there. What times what gives me a -7 when added together gives me a -6? Well, there's not very many factors of 7. 7 and 1, right? It has to be, the minus has to be bigger, so it's -7 and a +1. Times that gives me -7. Nick, are we struggling with the staples there?
It's like, it doesn't
There's
work.
staplers like, or there's staples like on the sides or something.
It doesn't work.
I think it's on.
So, and again, odds are, kids, it's probably number 3 that you're gonna have to do that on tomorrow's test. I don't know, I haven't really looked at it. Well, I should look at it. I got it sitting here, let me just look at it. That would help you out, wouldn't it, please?
Yeah. And like there's staples in the sides, and I got all the staples out, then I'm like, no more staples
Here, let me give you some notes here, looking at tomorrow's test. In the first 4 problems, there are 2 of them that you can do this with. 2 of the first 4 problems you can take a common factor out of. And I won't tell you specifically which ones, 1 and 2, that they would be. So beware of that tomorrow. Christine, which one? 15 or 13? Not this one? 11, 12, 13, 14, 15. This goes back to what we did probably, a month ago? Solving by elimination. In order to do that, you want 2 terms to go away when you add the equations together. So in order for that to happen, they have to be opposites. As I look at these, are there opposite terms here? Which are what? Yeah, these are opposites, so if you add them together just as they stand right here, 5x minus 5x is no x's, 8y minus 4y is 4y, and 28 minus 16 is 12. So solving that for y, you just divide by 4, y equals 3. That one should have been easy. The other one probably gets a little harder. Then you need to take that 3 because you want to know what both x and y are. You need to take that 3 and put it in either of the first 2 equations you started with. It doesn't matter. I don't know. I'm not sure which one I would do. I would pick the second one. Okay, I'm going to take, let's switch over here because I got some room. I'm going to take negative 5x minus 4y equals 28, and I'm going to put in for that letter y 3. So right here I'm going to put a 3. Negative 5x minus 4 times 3 equals 28. 4 times 3 is 12. Move that 12 over there, I add 12. So I end up with a negative 5x equaling 40. Divided by my negative 5. Negative 40 divided by negative 5 is a negative 8. And that's what goes here. Negative 8. Now, this one, children, 16 to me is by far harder because none of these cross off right now, and in order for you to get them to cross off, you're going to have to do something to both equations. Okay? Because there's no common factors there. What would be the most logical thing to do? Because there's multiple things you could do, but the most logical that would take the least amount of work would be to multiply what by what and what by what? Jake?
Multiply 3 by 4 and 4 by 3.
Right, because these are already opposites. You don't have to worry about the negatives. If you have 3 and 4, what's the smallest thing? They both go into 12. So you would multiply the top all by 4s, and you multiply the bottoms all by 3s. And when you do that, you'll get positive. You want me to do this or not?
Yes.
Fine. So I do that. Multiplying the top, I get negative 12x minus 28y equals negative 28. To the top. On the bottom, when I multiply by 3, I get a positive 12x is what I want because they're opposites. Minus 24y, get some big numbers here, minus 24. These go away, which is the reason I did all that. Here you just have to be careful with your negatives. 2 negatives give me a bigger negative. This is negative 52y equals negative 52. Which doesn't work out that badly because it's just going to be 1 divided by negative 52. Y equals positive 1. And the same thing is true. I can take any of these equations and put 1 in and see what x is. I probably would go with, I don't care, maybe the bottom one, 4x minus 8 times what y is, which was 1, equals negative 8. I get negative 8 for that. Add 8 to negative 8, I get 0. Can 4x equal 0? Yes. You can divide both sides by 4. X should be 0. Is that what the answer was? I don't remember reading that answer. Yeah. Nothing on the shading or the graphing stuff there. Here would be my other note to self, people, because this is where people go wrong all the time on this. I told you this when we did this for the last test. Let me look and see if it comes up on here. Yes, it comes up on here, but I'm not going to tell you what problem the ranking is. Oh, it's the same one. Right away when you look at this, because this is an inequality, you know it's going to be shading. Okay, and the y is the letter that tells you whether you shade up or shade down. Because this is a negative y, you always think opposite of what that sign is. Okay, so you are, this says, right now it says shade on the greater than side, but because of that negative, you're actually, after you graph this, you're going to shade the negative side. This says greater than, you're going to shade the one. And it's just a matter of this. People, how are you going to graph this? This one doesn't work out very well. But it's in standard form, and the way you graph standard form is to, I'm not going to make you be super exact on this, but you got to be close. I would do this with x, y intercepts. Put 0 in for x. 0 for x. If I have a negative 2y equals 2, what does y equal? Negative 1, because you divide by negative 2. So here where y is negative 1, I put a dot. This is where it gets a little dicey. Now I have put a 0 in for y, and I have 3x equals 2. Doesn't work out nicely, but you can do something with it. What do you get? Divide by 3 ends up being, Calvin? 2/3. So 2/3 on the x-axis, you just have to take a good guess. It's going to be a little bit before 1. And I don't care. Those are 2 dots are close enough. It's equal to, so it's going to be a colored, it's going to be a solid line. Okay? And it's just going to be a solid line like this. That would be close enough for governance. And like I said, this is the greater than side, so originally you would think that you'd shade the top half because that's where y is greater than, but y is negative, so you think the opposite, and you should be shading this side of it. Find the point on the y-axis, you're shading the minus side. And again, not that that would happen on tomorrow's test, but it may, problem 19. Can't give you too many more hints than that. 18 is in standard form, which I'm sure everybody is happy with. Y is positive, so you're just going to shade the positive side of the y-axis. We'll just do it because it's really easy. Crosses the y-axis at negative 2. Has a slope of negative 7/5, so up 1, 2, 3, 4, 5, 6, 7. If I go this way, it's positive slope, so I gotta go this way for negative slope over 1, 2, 3, 4, 5. There's no equal sign there, so this is a dashed line. And it's greater than, so you shade the greater than side. Oh, so much math, so little time. Evan, sir.
Can you do problem number 17?
I love 17. I can't read it, but I can do it. Oh, I can't go any bigger. Wait. How many people got 17 right? Couple of you? Does anybody remember what step number 1 all it said to do in these problems is to do what? If it's a word problem, the first thing you should do is, yeah, I called it defining your variables. You need to say what are your two unknowns? I want to know how much Grace
A cherry pie.
and a right. So I would make C equals dollars for cherry pie, and P is dollars for pumpkin, and then just write my equations from there. It says that, let me look at it, sorry. 4 cherry pies and 1 pumpkin pie cost, is that $30? 4 cherries plus 1 pumpkin equals $30. 4 cherries and 5 pumpkin pies cost $86. And then it's solved just like our systems of equations before. This one's not so bad. There are no opposites, but to make them opposites, I just have to multiply by what?
-1.
Yeah, just change them all to their opposite signs, actually. And it doesn't matter which one you do. Here's where you could probably save yourself some time. If I make this negative, it's going to give me negative answer there when I add them. So I would probably pick the top to make negative so that you end up working with positives. Minus 4C, minus 1P, minus 30. Goes away. 4 pumpkin pies are going to cost $56. Divided by 4, divided by 4. Pumpkin pies, for some unknown reason, are $14. Meanwhile, I have to put that in one of my equations up here. If 1 pumpkin pie costs $14, I subtract that from my 30. 26, wait, that isn't right. Is this cherry pies or pumpkin pies? It is pumpkin pie, right? What did I do wrong here? 14, oh, it's 16, sorry. And 4 goes into 16, $4 for the cherry pie. Pumpkins are harder, maybe they're not in season as much as cherry pie. Jake?
Problem number 16.
16?
Yeah. I got y equals 1, and then I put 1 into the equation, but I did the top one, and I got negative 3.
Is this the one you did? Negative 3x
Yeah.
minus 7y equals 7?
Yeah.
Well, let me do that. What was it? Negative 3x
Yeah.
minus 7y equals what?
Negative 7.
Negative 7. And y equals 1, right? So you get negative 3x minus 7 times 1 is a minus 7. Correct?
Yep.
And then when I move that 7 over, I have to add 7 to both sides.
0.
That's what I got, wasn't it?
You got 4. 4? Y was, oh.
Oh. Were you talking about the 4 I just got now for the cherry pies, or?
No.
Alexa, loops. Number 14. This one's by substitution, kids, and unfortunately, let me look on tomorrow's test and see if that's going to be the case tomorrow. You would look at that and say, boy, I wish we could solve that by elimination. Yep, tomorrow's test may be the same problem. In order to solve by substitution, you need a single letter by itself equal to something. And that doesn't happen here because these both have the letters on the same side. But one of them is the easiest thing to do. You can do any of them, but your life would be very complicated if you didn't pick this one. Which one would be the easiest to solve for what number? Michael? Top one for, right, I want to take this. I want x plus 2y minus 5. I want to solve it for x, so I'm going to subtract 2y to the other side. So now I know what x by itself equals. And then once you know what x equals, you take what x equals and put it in for what x is right there. So it's going to look like this. A negative 3 times what x is, which was all over there, minus 4y equals 7. And if we do this out, we get plus 15 plus 6y minus 4y equals 7. I don't like substitution very well. How do I solve this? The first thing I have to do is combine like terms. 6y minus 4y is 2y. I still have the plus 15 equaling 7. Subtracting 15, 2y now equals a negative 8. So y equals a negative 4. Divide negative 8 by 2. And once you know that, if y equals what? Negative 4, you can just put negative 4 in for y right there and see what you get for x. Negative 5 minus 2 times negative 4 from down here gives me a positive 8 minus 5 is 3. It gets to be a little. And that's why I would suggest that for these problems, you get one of them papers back there and do it in a big piece, because mine got a lot cramped in here, you really shouldn't. If it's a struggle for you, keeping it all straight, I definitely would get a piece back there in a big square and do it all out nicely, have it tore out. Do you have a question? No. Nobody else had any of those people on graphing things? You see any manual? No. You're still back up here in 12. Yeah. You're just looking for equal signs. Is that equal 6, right? Or is it equal 6 there? Yes? Yeah. Equal signs just means you're looking for where the two lines cross. What type of equations are those? Those are in standard form, which means x, y intercepts for both. For the first one, what does x equal if you put 0 in for y? 6, thank you very much, which happens to be off the graph, but we'll put it there. Y then equals negative 2y equals 6, so y is negative 3. And again, 9. And there is your line. I'll just draw it here. Or maybe not. That's a straight up line. You have to be pretty accurate with this, because otherwise you will find yourself not. Let's save those right there. Graphing the second one, 0 in for y, x equals negative 2. Negative 2? Negative 2. 0 in for x, y equals negative 1, right? Negative 2 divided by 2. And graphing those two lines, children. And here again, my line's a little off, but if you did it more accurately, I'm guessing it crosses right here. Which happens to be, it looks like positive 2, negative 2.
Number 22.
20 also. Oh yes. And I don't know what to tell you on this, kids. I will agree that this is by far the most difficult one probably on this entire test. But you know a couple things. You know that it's what shape? A parabola. You are going to graph something that's going to look like that. Now where that, is it upside down? No, it's not. If it was negative, it would be upside down, but let me check the test for tomorrow. Do we have to worry about upside down parabolas? And survey says no. Okay, the next thing I would do would be to do this. Establish what A is, what B is, and what C is. A is the number in front of the x squared, B is the number in front of the x, and C is the number that's out here on its own, which happens to be plus 0, or just 0. Are you with me on that? And this is what I write in my notes. In your notes, After you establish this, you need to find the axis of symmetry, which is what you get when you have negative b over 2a. And that's, some people don't like to write that out, and they find themselves getting it wrong because they don't write it out. A negative b over 2a. b is negative 4, a is 2, so you end up with a positive 4 over a positive 4. So the axis of symmetry is at 1. Right here at 1. I hope that's right. You know your parabola is centered around that. You just need to figure out how low it goes and how wide it's getting at what time. To figure out that, step number 3 is you put the axis of symmetry into the equation, into the original. I'm going to put my number 1 in for these x's and see what y is, because that'll tell me where, how high or low that on that axis of symmetry it is. If I put 1 in for that, 2 times 1 squared minus 4 times 1 plus 0, I end up with 2 minus 4, which happens to be negative 2. On this axis at negative 2, that's the lowest point of my parabola. Did I do something wrong?
Isn't it 2 squared?
No, it's 1 squared. It's only the x that gets squared, not the 2, because it's only the x. If this was all in parentheses, yes, but it's only the x. And if you even got those 2 points, odds are I would probably give you credit for the problem. Please understand this, whatever this number over here is where it crosses the y-axis. So I automatically know at the point 0 on the y-axis it crosses the y-axis. And you know it's symmetrical about that point, so you can put a dot on the exact opposite point of that side. So I've got that. I would love for you to stick another number in there, but hey, I can only expect so much out of you. Your parabola is going to look like this. Again, probably the hardest El Problemo on this here. Espanol. I would like nothing more or less. Somebody tell me what I'm going to tell you about 23. The thing to watch on 23 is, Grace.
It's gonna end up being
Okay, first of all, in your notes, I don't care if you write this down. If it's a square root function, your graph is going to look like the Nike Swish. It's going to start at a point and go up that way. If it's an absolute value thing, it's a V, correct? And if it's an x cubed thing, it's going to be this little shape here. You just need to know where those things start. And in this one, children, what am I going to tell you? Where's where people go wrong with this? This is the y number. This is the x number, except, Christine.
it's not supposed to be negative. It's supposed to be
Okay, yeah. Does that say negative? Right. You think this minus means you go to this side, but it's actually opposite and it goes to the other side. So when you see these two numbers, yes, it is up 3, boom, 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 but it's not to the left 3, it actually goes to the right 3. 1, 2, 3, 1, 2, 3. There is the start of your Nike whatever switch thing is. And that's the same as it is for, where's the other one? Is there no other one? X cubed, you don't have anything next to the x cubed, so it's right there at -1. You're just graphing that little thing like that. Did we have, oh, the V. Where's the V? Over here. Oh, there is no V? Oh, below, sorry. Same thing is true with this. Okay, you can put a +0 there. That's the y, add 0y, but instead of that, is that a -2? Instead of that going backwards 2, whatever's inside that, you actually go this way. And it's a V, so it looks like this. all little helpful hints that maybe, just maybe, we got close now. Any of those other things, back on page, none of the double shading stuff, everybody was happy with the double shading? Was that on this page?
Yeah, it's in the
And the only difference between these two is this is in slope intercept form, that's how you graph those two, and this one is in standard form, that's how you graph those. 21, again, this is where you gotta watch out, because that's a minus y. That means when you think about graphing this sign actually turns to greater than, not less than. Are we gonna do it or no?
Yeah.
Yes, let's do it. And again, getting close enough is gonna be good. If you take a look at the top of this here, and I'm graphing that, if I put 0 in for x, y equals what? Negative 3y equals 9, means y equals positive 3, because a negative into a negative is positive, so there's going to be a dot there. 0 in for y, I get 4x equals negative 9. If I divide negative 9 by 4, I end up with negative 2.5. So that's my, what was that, my x. Negative 2.5 is right here. Just a test note if you want to grab it on the back, right there, here's a test note. And it's not equal to, so it's a dash line, and this is what I was talking about. Originally that was the less than sign, which meant you should shade here, but it's a negative y, so you actually shade the top side of it. Doing the other one, 0 in for x, y equals negative 3. 0 in for y, x equals negative 6, don't have it, but we'll adjust. This one is equal to, so it's a solid line. You are shading the less than side, so you're shading this. And the answer is actually where you see the blue and the red, which is just this little chunk right here. That's really the only answer to that. Wake up, Jake. Big tournament. Ladies and gentlemen. This one you don't have to worry about because y is positive, so you're going to shade the bottom side of both of them. Stop, are you seeing stop there? You can't take anymore? Again, I will put this on Just Confusing. Let's look at that just because, hold on. Can I get that there? Just to show you where to find it, just in case you're wondering. I could take a video of me giving a video, that would be like going back in time.
Yes.
Or justconfusing.com, you find a very lovely picture of Sir Albert Einstein. You will see here, children, you are in 8th grade, so you click on the 8th grade tab. There are years all the way back to 2012 when you were 5th grade or something like that. You clicked on the 2015. It'll probably be down here, the last one on this. This is the only ones I have on there. These are all the ones since we got rid of that other book thing. So these are all systems of equations, graphing absolute values. Oh, look, there it is. Full life. And it's not very clear, but it's like a little imagery. It isn't very clear, but I think that's because it's light in here or dark in here. And I don't know how to get out of it. How do I get out of it?
Stop it.
What?
Stop it.
What?
It's from you.